y'all doing? Today we are going to be doing selection sort. So let me change this to, well, if I change this, I have to change the file name. I'm going to leave this as this. If you do want to understand the boilerplate code, just watch the bubble sort video. That's where I explained it. I just create an array, that's random numbers, and I just print them out really. Selection sorted array. Okay. This right here, this is not a selection sort, this is a bubble sort. I'm just using the picture as an example. So first, we're going to go through theoretical, just like we always do. Selection is, okay, this is how you want to remember selection and how you differentiate it. Selection is the humanized way of sorting. Okay, this is usually how most people will sort. So when you look at this array and I tell you, how would you sort this, you yourself? You would, and I tell you, let's say you sort it from smallest to biggest. So you'll do is you'll scan it with your eyes and be like, oh, this is the smallest one, this will be 2. Then you'll scan it again, oh, this is the smallest one, this would be 4. Then you'll scan again, 6, 7, 9. You see what I mean? So this is basically exactly what selection sort is the most humanized way of sorting, where you scan the array, find either the biggest if you want it to go from biggest, or you find the smallest if you want to go from smallest, and then you put it in the beginning. So what we'll have 2 loops. One loop will keep track of the sorted section, so which is going to be I. I is going to be at the beginning, okay, because we're going to first take this number and we're going to compare it to the whole array. Which one is smaller than this? The smallest one. Then we're going to take it, put it here, then we're going to move I here, because this is now the smallest one, so we don't got to worry about it. So I will move this way. Then J, well, actually J doesn't matter. J will start from where after I. J will start after I, right? And then we'll compare this to I. Oh, is this the smallest one? Okay, we'll hold this value. Then it will go again. Is this smaller than I? Oh, well, no, not I. Is this smallest from the one we're holding? Is it? No. Okay, go next. And then we'll keep going. Oh, wait, this is the smallest one then. And then I'll swap it. Okay, so that's basically what we're going to do. So first, we want to first loop forward with a for loop. So for int I equals, so we're going to start at 0 at the beginning. And then we're going to do I less than array.length -1. Well, we don't need -1. So for this one, if you guys watched the bubble, we did do -1. Not for this section. For this section, we did -1. Why is it like that? Because remember, we said array.length will not return the array length by indices. So it won't start from 0. It will start from 1. So the length of the array on the right is 5, right? There's 5 numbers. When I do array.length, it will give me 5. But if you think about it indice-wise, it's from 0 to 4, which is also 5 indices, but it starts at 0. So since this is not equals, when it gets to 5, it doesn't loop because 5 is not an indice. So if it's equal, when it gets to 5, it will loop one more time. But then you'll get an out-of-bound error exception, which means you're trying to reach somewhere that's not there, which is the 5, because remember, indices is whatever -1. So not putting the equal works. If you do want to put the equal, you'll have to do -1, so that this will get to 4. And it will loop the 4, and then it'll stop. So it's up to you. This is obviously the cleaner way to do it. And then we're going to do I++. So this is the first loop that will go from the beginning to I as we increment. Now, what is going to be my second loop? Well, my second loop is going to check the whole array, compare it, get the smallest one in that array. That's what the second loop is for, is get the smallest one or the biggest one. So we're going to have J. Where do I want J to start? So int J. Where do I want J to start? Remember, wherever I is at is the right position. So when it first starts, well, I is not at the right position, so we will handle that. But when I is here, we don't want to check here. We don't want to start at 0. We want to start at where I is, right? Because this is assumed to be sorted, because in the first loop we found the lowest one and we put it. The only reason we'll check it is if we didn't find the lowest one, which wouldn't make sense. So every loop, whatever behind I, you will not change. So we're gonna start it at I. Okay? And then we want J. As long as J is less than the array.length, then keep going. Length, then keep going, and then J++. So this is the second loop. The job of the second loop is to find us the smallest one. So where is the current index at? So we're going to do int current index equals I. Now I'll go over why we do that. Because, well, we know that, well, we want this to be the current index, or I, it doesn't make a difference. So we want to start from the current index and go forward. Then, whenever we get a number, so let's say j right now is, so when it first starts, j is going to be at the current index, which doesn't make sense because we're going to be comparing the current index to the current index. Therefore, we want j to start one ahead of the current index. Okay, so then j will start here. Then what we want is to check, is this the lowest number? So we're going to do, out here, we're going to start a variable, or actually, we can use this as the thing is, if I name it the minimum index, which is, the current minimum, if I is at 7, and we haven't compared it to anything, we're going to assume 7 is the minimum number. However, if you want to change this from, ascending to descending, you'll have to change the variable names, from minimum index to maximum index, which is obviously annoying. So I'm just going to name this index. But remember, this index will hold either the minimum index, the current minimum, or the current maximum index we just found. All right? So we want j to start at the index, right? Now, what do we want to do with that index? First, since we have the minimum index, we'll say, well, that's my minimum index. If the array at j is less than, so we're going to be doing from minimum to maximum. If array at j is less than the array at this current minimum, okay, so what am I saying here? Is I'm saying, first, we're going to set I at the beginning. So let's do that. I is going to be at the beginning. Then I'm going to set I as the minimum. So this is going to be my minimum. That's what I do here when I save it at an index. All right, that's going to be my minimum. Then I'm going to start another loop, which starts here, right, at index plus 1. And then what I'm going to say is the array at j, which is 2, is 2 less than the index? It is. That means this is my new minimum. So then I'm going to update it. So index equals j. So okay, sorry, I have to answer somebody. But so index equals j. So what I'm saying now, that's the new minimum. That's the new is not the actual number I'm holding. I'm holding the index of that number. So that is the new minimum index. And this loop will go again, right, without updating. So then this will go again. Okay, j is here. Then what I want to compare is j smaller, but I want it to compare, is it smaller than this, right? So I can't do array at the index. But remember, I updated the index. So that's what I'm trying to make sure you guys know, is that after I updated it, my index is no longer this minimum. Because I changed it, when I do array index, it's going to be the updated index, which is the 2. All right? So it will automatically compare it to the 2. And it will compare it. Is it smaller? No. We'll go to the 6. Is it smaller? No. We'll go to the 4. Is it smaller? No. So now I know that I got the index of the 2, which is the smallest one, which happens to be 1. Right? That's the index. And I is at 0. So now that I know that, I want to switch them. Okay? So I'm going to say here, I can do if the index does not equal I. Why do I do this if statement? Is basically my way of saying, have I found a new minimum? If I didn't find the new minimum, there's no point in switching them, right? But if, I mean, technically, you don't need to change it because you could still do the swap, and you swap, like, let's say 7 is the minimum. If I don't do this if statement, then the swap will still happen, but the index and I will be the same thing. So I'm going to be swapping 7 with 7, and it won't change, which is the right thing to do, right? Because if that's the minimum, I don't want to change it. However, if we're talking like efficiency, then why would you swap something that you don't need to swap? So if the index is not I, it means there's a new minimum or there's a new maximum. Therefore, do the swap. And so that's what I'm going to do here. How do you do a swap? We spoke about this in the last lecture. First, you want a temporary variable, and this is going to be I. So remember, this is going to be the 7. And then I'm going to replace the 2, which is array at index. I'm going to replace that. Well, actually, I'm going to replace the 7 with the index. Okay, so now what I did here is first I took 7 and I stored it somewhere. Then I made 2 go where the 7 is. Okay, let me leave this. Then I said array at I, which is the 7, equals the array at the index, which is the 2. So this became 2. Now what I'm going to say, okay, then array at index, which is the 2, this 2, right here, this is going to be equals to the 7, which is the number I just stored, aka the temp. So you see, now I'm going to store them. And this loop will keep going until it finds the minimum, puts it, then I will increment. Now I will be here now. And then the loop will start again. So let's see if this works properly. We have selection sort, and it's sorted right. One thing, if you want to switch it to minimum to maximum, this is the section. So as soon as you switch that, it goes descending, and then if you switch it back, it goes ascending. So that is it. If you guys want to go into understanding time complexity of bubble, selection, or insertion, go to the end of the bubble video. That's where I explained it. So I'm not going to explain it again because it's the same for all three. For this one, it's the same as the bubble, which is O(n) squared. All right. Memory-wise, bubble, selection, and insertion don't use up any memory. So that's that. And that's about it for selection. I'll see you guys in the next one. That is insertion.